In the following diagram, ABC, D, and E lie on the circumference of a circle, center O. Then BD is equal to BE, angle CAD is equal to 18 degrees, and angle BEC is equal to 51 degrees. Okay, so if we look at our diagram, those are the values that we have. The first question is saying find angle ADC. Okay, so if you look at the angle that we are looking for, that is ADC. Okay, so ADC is very easy and straightforward. If you look at the way this one is, if this is a center here, we have this theorem where we have the diameter. Okay, so the diameter, once it subtends an angle on the circumference, so once it forms an angle on the circumference, that angle becomes a 90 degree. So this AC is a diameter. Okay, so this angle that has been formed on the circumference, the angle D there is actually 90 degrees. So angle ADC is equal to 90 degrees. Okay, we move to angle BED. Okay, so B and then ED. Okay, angle BED. This is the angle that we need. Now here we've been given angle BEC, which is 51, but we want this other part here so that it can be added to 51. Now this part here, very easy. Come back to this side. Have you seen this? DC. Okay, DC is a chord. Now we have angles that are coming from this same chord. So angles that are coming from the chord DC is angle A, angle E, this smaller one here, okay, and this angle right here. Now the theorem is saying if angles are coming from the same chord and they've been formed on the at the circumference, the theorem is that those angles will be equal. So here we have 18. It means even this part here is 18. Okay, so we're just going to add 51 plus 18. Okay, where we're going to have that is a 9, so 69 there. So 69 degrees is the value here. Okay, so we just added, we've applied the law where angles are coming from the same chord. Okay, we proceed to the last one. We need to find angle EBC. Okay, angle EBC. So angle EBC is the entire angle here. Now remember, we were just talking about angles coming from the same chord. So this one here, we already know to say this is 18 because it is coming from this chord where we have 18 here, 18, so even this is 18. So if I can know this angle here, we can just add 18 plus this angle here. Now how do we find this angle? If you look at this triangle here, look at this triangle starting from B, going this side to E, coming to D, coming back to B. This triangle here is an isosceles triangle. As you can see, it has sides, two sides that are equal to each other, meaning the angles down here, they're supposed to be equal. Good. So since here we found as a 69, it means even here where there's D, it's 69. So we cannot fail to find this. Okay, what we're just going to do is on the other side, we're just going to add 69 plus 69 first of all. We're adding these two angles here and subtracting them from 180. Okay, so this is 18, carry 1, then 6 plus 6, that is 12 plus 1 is 13, so 138. Now we found 138 when adding these two. Remember, angles in a triangle, they add up to 180. So when we add these two, we need to subtract from 180 and then we're going to get this angle. So the remaining angle will be for this part here. Okay, and that is what we need. So we're going to say 180 minus 138. Okay, so this is a 7, this is a 10, so 10 minus 8, that is a 2, and then 7 minus 3, that is a 4, 1 minus 1, that is a 0. So the answer is just 42. So it means here, now we have a 42. Okay? Remember here we have 18. So the complete angle that we want is angle EBC. Okay? So EBC, this angle will just be 42 plus 18. Okay? So 2 plus 8, that is a 10. 1, 0 carry 1. And then 4 plus 1, that is a 5, plus 1, that is a 6. So the final answer is 60 degrees. That is the value for angle EBC. Okay, so whenever you're handling the questions under circle theorem, you have to make sure that you apply all the laws. Okay, remember all the laws just by looking at the diagram. So the first one, we applied the angles being formed by the diameter being a 90 degree. The second one, we applied angles coming from the same chord to say they are equal. And then the third one, we applied angles coming from the same chord, of course. Then the fourth, we applied now angles in an isosceles triangle. Okay, this is an isosceles triangle having two sides that are equal. Okay, thank you very much.